Hello, everybody, and welcome to Tuesday. This is Average Rate of Change Part 2, and today we're going to learn how to find the average rate of change from a table and a function, and then we're going to graph both the function and the secant line. So if you've not already done so, please open up the presentation below and follow along with me as I do the work here on my copy of the slides. So here we go again we know that functions are all about modeling and predicting change, and the average rate of change is the same thing, a way to model and attempt to predict change. So to review what we went over and learned yesterday was we learned that if the graph of a function is not a straight line, the average rate of change between any 2 points is the slope of the line containing the 2 points, called the secant line. And so we know that a linear function has a constant rate of change, but when we have something that is nonlinear, like we see here the growth of the boy into manhood, this is a curve. And so the best we can do is find an average rate of change between the 2 points. And so we did that using our slope formula. All right, we did that using the slope formula. So what we're going to look at today is, first of all, when we're looking for the average rate of change, we're looking at it over what we call intervals. And an interval is a set of numbers with given endpoints, and they are always x values. And the reason they're always termed as x values is because we are finding the rate at which the outputs are changing as compared to the inputs. So you see your notation right here where we have these two brackets in -2, 1. So these are the endpoints of your interval. So I went ahead and graphed these as the lines x equals -2 and x equals -1. So you could have a good visual of what we're talking about with an interval. And an interval is just a certain portion of the graph that we're looking at. And as you can see, we're looking at in an average rate of change, what is the graph doing over this interval? Okay, so interval can be written with these brackets. Intervals can also be written as x equals 2 and x equals 1. The interval, particularly with the table, can also be written as -2 less than or equal to x and x less than or equal to 1. So as you go through rate of change, you're going to see it modeled in these different ways. All right, so let's go ahead and start with the average rate of change from a table, which this problem says to find the average rate of change over the interval. 1 is less than or equal to x, and x is less than or equal to 5 for the table below. And the way you do this is by using the slope formula. So if I go over here to my Canvas board, I have this problem set up, and I'm looking at the interval of 1 less than or equal to x, and then x less than or equal to 5. So if I'm going to use my slope formula, which is m equals y2 minus y1 over x2 minus x1, I need to find an x1 and a y1 point and an x2 and a y2 point. So I'm just going to select this first endpoint as one of my ordered pairs. So that's going to be x1 and y1. And then I will select this other endpoint as my second ordered pair. And that's going to be x2 and y2. So now I've got 2 points that I can plug into the slope formula to find my average rate of change. So y2 is going to be 27 minus y1, which is 3, over x2, which is 5, minus the x1, which is 1. So 27 minus 3 is 24, and 5 minus 1 is 4. So my average rate of change over the interval of 1 less than or equal to x and x less than or equal to 5 is going to be 6. All right, that's my average rate of change. Now, if we go back to our slides and look at our next problem, it says here, and this is the average rate of change from a function. It says to find the average rate of change of the function f of x equals x squared plus 3x plus 5 over the interval -2, 3. Then find the equation of the secant line and graph both using Desmos. All right, so here's how we're going to do this. Is when I come over here to my Canvas board, I will write the function f of x equals x squared plus 3x plus 5. And I'm looking at it over the interval of -2, 3. Okay. Now, I need to remember what I already told you. When I'm looking at the interval, these are both x values. So -2 is going to be x1, and then the 3 is going to be x2. So what I'm going to do is substitute each of these x values into the function so I can get an output of a y value and use that to write my ordered pair. So if I have the f of -2, okay, so I have 4 minus 6 plus 5. So that means that the f of a -2 is going to equal 3. So the first ordered pair that I have is -2, 3, and this is going to be my x1 and my y1. Now, the next thing that I'm going to do is take the x2 value and substitute that into the, into the same function. So when I do that, I have the f of 3 equals 3 squared plus 3 times 3 plus 5. Okay, so here my f of 3 is going to equal 23, because 9 and 9 is 18 plus 5 is 23. So that means my ordered pair for this interval, for the second bar of this interval, is going to be 323. So that's x2 and y2. So now that I have 2 points, I can plug both of those points into my slope formula to find the slope of the secant line. So y2 is going to be 23 minus y1, which is 3, over x2, which is going to be 3, minus a -2. So before I go any further, I'm just going to clean that up a little bit. So that's going to be 23 minus 3 over 3 plus 2 is 5. So my slope here, or my rate of change, my average rate of change over this interval is going to be 4. Now, the next thing that I need to do, because I want to write the equation of the secant line so I can graph both the function and the secant line. So I'm going to use my x1 and my y1 to do that. So using the point slope form of a linear function, my y1 we said was 3. And then we said the slope was 4. And then my x1 is going to be -2. So again, I'm going to clean that up real quick. Now I'll go ahead and distribute my slope. And then I will add the y1 to both sides since it's being subtracted. So y equals 4x plus 11. All right, so when I go to Desmos now, I'm first going to graph the function. So the function is going to be f of x. All right, so there's the function. Then I'm going to graph the secant line. So that's going to be y equals 4x plus 11. So there you have it. There is your function with the secant line. And so you can see here, you have your point here and here. That's the interval that we measured over. And the average rate of change over this interval is 4. And we just paste it right down in there, right like that. All right, so there's your function and the secant line. All right, so let's do one more together. And then I think you might be able to handle this. It's a lot of work, I know, but as we progress in our math career, it's going to take more time and more steps to solve more complex and complicated problems. All right, so we have here the average rate of change from a function, and we want to find the average rate of change of the function g of x equals 4x squared plus 3x minus 5 over the interval -1, 1. Then find the equation of the secant line and graph both using Desmos. Okay, so let's go ahead and go over here and get a new drawing board. And we're going to have the function f or g of x equals 4x squared plus 3x minus 5. And we're graphing this or looking at this over the interval of -1, 1. All right, so here's my x1 and here's my x2. All right, so let's start with the g of -1. So -1 squared is 1 times 4 is 4, minus 3 minus 5. Oh, excuse me, that should be a 4. Or -4. Okay, so my ordered pair here is -1, -4. So that will be my x1 and my y1 for my slope formula and point slope form. So now let me take my x2. So here my ordered pair is 1, 2. All right. So now what I need to do is use my slope formula to find the slope of the secant line. which is going to give me my average rate of change over this interval. So y2 is going to be 2 minus the negative 4 over x2, which is 1 minus the negative 1. So if we clean this up just a little bit, that's going to be 2 plus 4 over 1 plus 1. So 2 plus 4 is 6 over 2, which gives me a rate of change of 3. So my average rate of change over the interval -1, 1 is going to be 3. All right, so now I take this ordered pair, x1, y1, and my rate of change, and I go to my point slope formula and plug these numbers in to find the equation of the secant line, so then I can graph my secant line. So here, my y1 is going to be the -4. So let's just clean that up, make that y plus 4, and then we'll clean that up as well. All right, so there is the equation of my secant line, y equals 3x minus 1. So now I will take that equation and my function, and I will come over here to Desmos. All right, so there's my function. Then I will take my y equals, and we said that was, I forgot, 3x minus 1. All right, so there you see again, there is your secant line, and it is illustrating your average rate of change over the interval. So here's 1, and here's 1 here. So there's your secant line. All right, so that is what you're going to be doing today, ladies and gentlemen. For your assignment, you've got 1, 2, 3, 4, 5 of these to do, okay? And then at the end of it, I say to please insert a photo of your work here. So please include a copy of your work so I can see how you arrived at the problems, and also if you got any wrong, I can see what it is that you did wrong. So basically, this is all you're going to do is do the work that I just showed you, find the equation of the secant line, graph both the function and the secant line using Desmos, put the photo here, and then when you're done, upload a copy of your work to Canvas on this particular slide, since we're working with an embed. All right, so if you have any questions or need assistance, you can meet me on Google Meet during 10:45 to 11:45. Also, you can email me, and I will get back to you as soon as I can. So have a great day, and remember your progress check for tomorrow, okay? Goodbye.